Today, we will see increasing and decreasing functions. Is the application of derivatives. Uh, in that, what is mean by an increasing function? So much theoretical part is there, but the only one concept you have to keep in your mind that when we say that the function is increasing and when we say that the function is decreasing. Okay, let us start. F is said to be monotonically. Monotonically means strictly increasing function on the interval AB if for any x1 and x2 belongs to that particular interval whenever x1 is less than x2, x1 is less than x2, value of the function must satisfy the same inequality. So whenever x1 less than x2, f of x1 must be less than f of x2. Okay, look at this figure. When we see that function is increasing, can see that the function is increasing. How it is increasing? Whenever x1 is here, x2 is here, and the value of the function f of x1 is here, f of x2 is here, and it is more than x1, f of x1. So f of x2 is greater than f of x1, or one can say that f of x1 is less than f of x2. So if this is the case, then we say that the function is increasing. Now, let us consider some h is greater than 0, a small increment in x. It is very small. It is very small number, small positive number, and greater than 0. Suppose if we add that small positive number to x, what will get? We get x plus h, and definitely this x plus h will be greater than this x. We will take this x as x1 and x plus h as x2. So we get f of x is less than f of x plus h. Definitely, because function is increasing. Now function is increasing. So if we write this as f of x plus h is greater than f of x, subtract f of x from these two sides, we get f of x plus h minus f of x is greater than 0. Now h is greater than 0. H is non-zero. We can divide this by h. So we divide this equation by h. So this is greater than or equal to 0. But we can think of this f dash of x is greater than or equal to 0. If you find the limit of this function, the limit of this function is f dash of x and limit of 0 is 0. So limit of taking limit as s tends to 0 is nothing but the definition of the derivative, first principle. So f dash of x is greater than or equal to 0. That is f dash at a is greater than 0 in a small delta neighborhood of A. Now, what is meant by delta neighborhood of A? Delta neighborhood of A means an interval which contains the point A and having a small length delta. A minus delta to A plus delta. This interval is called delta neighborhood of A. So now we have f is strictly increasing. When we say that a function is strictly increasing, its derivative is greater than 0. So f of a plus h minus f of a is greater than 0. It means from one side. So from right hand side, the difference is greater than 0. On from left hand side, the difference is less than 0. So in that case, for 0 less than h less than delta, f of a minus h is less than f of a is less than f of a plus h. Means we are finding a point which is closer to this a such that to the left of a function is having smaller value and to the right of a the function is having bigger value. So we conclude that the function is increasing. Now, say on the same line, we have to discuss the decreasing function. Okay, on the same line, the function f is said to be monotonically decreasing function on the interval AB if for any x1 and x2 belongs to open interval AB, x1 is less than x2. Now, whenever x1 is less than x2, f of x1 is greater than f of x2. Okay, so this is different than the for increasing function. So here x1 and x2. x1 is less than x2 clearly, but the f of x1 is greater than f of x2. So in that case, it is clear that function is decreasing. Okay, so again, on the same line, we will take h is a small increment in x, then x plus h is greater than x. So f of x is less than f of x plus h, as we see here definition. Whenever x1 is less than x2, f of x1 is greater than f of x2. X plus h is greater than x, so f of x is less than f of x plus h. F of x plus h is less than f of x means f of x plus h minus f of x is less than 0. We can divide by h. Taking limit as it tends to 0, we will get f dash of x is less than or equal to 0. That means f dash at a is less than 0. Then in a small delta neighborhood of a, again delta neighborhood of a is open interval a minus delta to a plus delta. So f is strictly decreasing in this case. So when 0 less than h less than delta, f of a minus h is greater than f of a is greater than f of a plus h. So that for x is equal to a, to the left the function has having more value, and to the right the function is having less value. Now this is the case whenever the function is strictly greater than 0 or strictly less than 0 or only less than or equal to or greater than or equal to 0. But when the derivative becomes 0, what will happen? Okay, when the derivative becomes 0, point the tangent is parallel to x-axis. So at that point the tangent will be parallel to our x-axis, and we cannot say the function is increasing or decreasing. So at that point function is neither increasing nor decreasing. We can't say anything. Let us see some solved examples based on this increasing and decreasing function. Show that the function f of x is equal to x cube plus 10x plus 7 for x belongs to R is strictly increasing. We have to show that this function is strictly increasing. Okay. Now, how to show that it is strictly increasing? Okay. So, given function f of x is equal to x cube plus 10x plus 7. Then differentiate with respect to x. What you get? 3x square plus 10. Now we have to think of this value, whether this derivative is less than 0 or this derivative is greater than 0. If this derivative is less than 0, function is decreasing. And if this derivative is greater than 0 for all x, the function is increasing. If you see, this 10 is a positive quantity. Okay, so it is greater than 0. Now here 3x square. Now x square, if we put any value of x, we have to take its square, and square is always positive. So 3x square is also positive for every x belongs to R. So their sum is also positive for every x belongs to R. Hence, we conclude that this derivative is strictly greater than 0 for any x, any real number. So the function is strictly increasing function. The next example, f of x is equal to x cube plus 6x square plus 12x minus 5. Again, we have to test whether it is a decreasing or increasing. The only case is we have to take the derivative. So take the derivative, x cube plus 6x square plus 12x minus 5. So differentiate with respect to x. What you get? 3x square plus 12x plus 12. We can take 3 common, x square plus 4x plus 4. But if you see this quadratic equation, quadratic relation, it is a perfect square, x plus 2 bracket square. Okay, so for any value of x, it's a square, so it is always greater than 0. So f dash of x is always positive for x is not equal to minus 2. Whenever it is when x is equal to minus 2, it becomes 0. And when f dash of x becomes 0, we can't say whether the function is increasing or decreasing at that point. So f dash of x is greater than or equal to 0, greater than or equal to 0 for all x belongs to R. So function is increasing. I will not say monotonically increasing. I will not say strictly increasing. I will say only increasing, because here I am using less, greater than or equal to. So it is a increasing function for x belongs to R. Now this next problem is f of x is equal to x cube plus 12x square plus 36x plus 6. Monotonically increasing or monotonically decreasing. Take as usual the function, take the derivative of its, then take 3 is a common, then factorize this function, this quadratic relation x plus 2 into x plus 6. Now f of x is monotonically increasing. When we say that it is monotonically increasing, its derivative is strictly greater than 0. Strictly greater than 0. That means this is greater than 0. Now 3 into x plus 2 into x plus 6 is greater than 0. That means x plus 2 and x plus 6, this product is greater than 0. And now when it is possible if this first factor is positive, the second factor is also positive, so that their product is positive. And the other condition is this x plus 2 is less than 0, this x plus 6 is less than 0. In that case also the product is greater than 0. So we are getting two cases. This is the first case and this is the second case. So we'll go for the first case. X plus 2 is less than 0 and x plus 6 is less than 0. We have to find the proper x. We have to find the proper x. Now how to find? I will show you by graphically. Okay, this is your real line. Suppose here there is a 0 origin. Now take here x is equal to minus 2, then here there may be a minus 6. Okay, now this first inequality tells us that x plus 2 less than 0 means x less than minus 2. Okay, x less than minus 2. x कसा आहे minus 2 पेक्षा लहान. So this is first inequality, x less than minus 2. Okay, now what the second inequality, x plus 6 is less than 0. That means x is less than minus 6. x कसा आहे minus 6 पेक्षा लहान. So x is less than minus 6. This is the second inequality. Now we want both the statements must be true at the same time. So from this figure, can you conclude what is the solution set for these two equations? Obviously, the common part. Okay, obviously the common part is the solution set. So we must have x less than minus 6. If we choose x less than minus 6, definitely it is less than minus 2. So whatever the number we choose, which is below minus 6, it will satisfy both the conditions. So which is our solution set, x less than minus 6. So here the function is monotonically increasing. Now we will go for the second case. X plus 2 is greater than 0 and x plus 6 is also greater than 0. Now again I will show on the graph of this real line. There is one real line, then I choose I choose this as 0. Here there is minus 2. Here there is minus 6. Then what are the first inequality tells? X y. So x is greater than minus 2. So we want the value which is greater than minus 2. Minus 2 peksha मोठी. So this is the case only whether x is greater than minus 2. Now again think of the another one. Another one means this x is greater than minus 6. X हा कसा आहे minus 6 पेक्षा मोठा आहे. x minus 6 पेक्षा मोठा. परत तिथे चालू आपण which is the common part, which is the common part. So definitely the common part is this. X is greater than minus 2 is the common part. So x greater than minus 2. So here also function is monotonically increasing. Now first case says that when x is less than minus 6, function is monotonically increasing. In second case, we also see that the x when x is greater than minus 2, again the function is monotonically increasing. So we will combine these two inequalities together. We get x less than minus 6 or x greater than minus 2. That is, whenever x belongs to minus infinity to minus 6 and or x belongs to minus 2 to plus infinity, in both the cases function is monotonically increasing. Okay, so that means we can write it as set of all real numbers minus that particular interval. Now the same example, now we will discuss it for monotonically decreasing. When we say that the function is monotonically increasing, again we will go on the same line. Now here the product is less than 0. Now product is less than 0 means one of them must be negative. So x plus 2 is less than 0, x plus 6 is greater than 0. Or it may possible that x plus 2 is greater than 0 and x plus 6 is less than 0. So take the first condition, x plus 2 is less than 0 and x plus 6 is greater than 0. Though x is less than minus 2, I will again I will plot it on the graph. This is your real line. Suppose here there is 0, here there is minus 2 and here there is minus 6. So what is the condition? What are the conditions? So x is less than minus 2. Our x is less than minus 2. Minus 2 पेक्षा लहान. बरोबर? And what is the second condition then? The second condition is x is greater than minus 6. Minus 6 पेक्षा मोठा. Which is the common? Obviously this part is common. Okay, this is the part which is the common solution, minus 6 to plus 2. So the common region is open interval minus 6 to minus 2. So in that interval only the function is monotonically decreasing. Now and take the second part. Okay, now also I will show the second part in front of you. This is a set of all real numbers, real line. Here it is 0, here it is minus 2 and here it is minus 6. Now look carefully, look at this type. What is x? X is greater than minus 2, minus 2 and greater than minus 2. And what is the second inequality tells us that the value of x is less than minus 6. So minus 6 less. So there is nothing common to them. We can't choose a single x. Here we can't choose a single x which will satisfy both the conditions. there is no real number which is greater than -2 and also which is less than -6. So this condition does not arise. This is the so the function is decreasing only on open interval -6 to -2. So this is all about the increasing and decreasing function. Okay. In next lecture we will see uh, maxima and minima, how to find maxima and minima.